objective of this project is to figure out the time for the volume of the balloon increase and to determine the related rates height of the water rises as the teenagers get into the jacuzzi bathtub. Application of differentiation. Related rates. In differential calculus, related rates problems involve finding rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. Because science and engineering often relate quantities to each other, the methods of related rates have broad application in these fields. Differentiation with respect to time or one of the other variables requires application of the chain rule since most problems involve several variables.
For the first situation, James and John was in the fun fair when they suddenly saw a man selling a balloon. They realized when the balloon was being pumped, the volume of the balloon increased as the size increased. According to this situation, they figured out the rate of increasing and they want to know how quickly the volume of the balloon as it increases when the diameter is 10. For the problem statement, a spherical balloon is being inflated, so the diameter increases at the rate of 2 cm per minute. How quickly is the volume of the balloon increasing when diameter is 10 cm? For the problem solving, the spherical balloon is being inflated, so the diameter is increasing, which is dd over dt as the rate of 2 cm per minute. So we need to find the volume of the balloon as it increases, which is dd over dt when the diameter is 10 cm. We will be using the volume of the equation V equals to 4 over 3 pi r cubed because the question gave the diameter of the value. We sub the formula of the diameter into the radius, which is half of the diameter, and we have V equals to pi over 6 d cubed. For the next step, differentiate both sides with respect to t. dv over dt equals to 3 pi over 6 d squared dd over dt. Plug in dd over dt equals to 2 and d, which is the diameter, equals to 10. So the equation will be dv over dt equals to 3 pi over 6 10 squared times 2. For the final answer, it will be 100 pi cm cubed per minute.
Situation: Ali invited his cousin Abu to sleep over at his house. They both decide to take a bath together in Ali's jacuzzi bathtub. Ali realized that the rate of the water inside his bathtub is rising when he entered the jacuzzi bathtub. Ali started to wondering that how many rate of water will rising if Abu join Ali enter the bathtub together. Problem statement: what is the rate at which the height of the water rise when Ali and Abu get into the jacuzzi? Problem solving: the jacuzzi bathtub is in rectangle shape. If the length given is 300 cm and width is 200 cm. What is the rate at which the height of the water rises in the jacuzzi bathtub? The first step we need to do is we have to sketch the rectangle. The second step is we have to identify the rate of change, which is dV over dt equal to 50,000 cm square per second. The third step is we have to do the equation, which is V equal to length times width times height. The fourth step is we have to do the derivative. dV over dH equal to 60,000 cm square per second. The fifth step is the substitution, which is dV over dt equal to dV over dH times dH over dt. dV over dt is 50,000 and dV over dH is 60,000, and we need to find the dH over dt. We need to put the 60,000 to the left side and make 50,000 over 60,000 so that we can find the dH over dt. dH over dt is equal to 5 over 6 cm per second. The height of the water rise when Ali and Abu get into the bathtub is 5 over 6 cm per second. So, in conclusion, the volume of the balloon when its diameter increase is 10 cm and the rate of the balloon is increased at 2 cm square per minute is 100 pi cm per minute. John and James now have figured out the volume after the problem has been solved using the method-related rates method. And also, the height of the water rise when Ali and Abu get into the jacuzzi bathtub has been determined. The problem is already been solved. They both know the height if the water rise up when Ali and Abu gets into the bathtub is 5 over 6 cm per second.